Okay, this question, I'm doing question 6 now, which is finding the relative molecular masses of the following molecules, compounds. Right, so the first one is N2. Now, N is nitrogen, so we need to go to the periodic table and find nitrogen, which is right here. And you'll find that nitrogen is about 14.007. I'm going to take what I've got here, so 14.007 for nitrogen. I'm just going to use that, okay? Because if you are in an exam and you've got a periodic table like this one, you're going to use 14.07. Okay, so what is it? There it is. So we're going to do, and there's two of them. So two nitrogens at 14.0, was it 007? I think it was just 14.07. Yeah, it was 007. So 14.007, which means we just multiply by 2 and you get 28.014. Okay, so that's the mass for nitrogen. For sodium chloride, we look for sodium and chlorine. So sodium is right here, is 22.99, 22.99. So sodium is 22.99. And then you get chlorine. Chlorine is just here, and chlorine is 35.453. 35. .453. Okay, so to avoid wasting a lot of time, let me just go to the calculator. So let's see, 22.99 plus 35.453. That'll give us 58.44. So the total for this one is 58. Use a different color. 0.443. I'm using 3 decimals because I've got 3 decimal places here. You should always use the maximum number of decimal places, or if you're asked to put them in 2 decimal places, if it's specific, then you can be more specific. Let's look at calcium carbonate. So calcium carbonate is made of calcium and calcium. Let's have a look at calcium. So calcium is here and it's 40.078. Calcium is 40.078. Then carbon is right here, and carbon is 12.011. 12.011. Then we've got 3 oxygens. Okay, so be careful there. We've got 3 oxygens, and each oxygen is 15.999. Each oxygen is 15.999. So I've got to multiply this one by 3. Okay, so 15.999 times 3 will give us that. plus 12.011, give me that, plus 40.078, which gives us 100. So the answer to this one is 100.086. And the last one is magnesium, but we need to work this bracket out first and then multiply it by 2 and then add the magnesium. So inside the bracket we have nitrogen. Inside the bracket we have nitrogen, which is 14.007. So nitrogen, let's write them down first. Nitrogen is 14.007. And then the 3 oxygens are 15.999 times 3. And then we're going to multiply these by 2. And then we're going to add the magnesium. And the magnesium is 24.305. So 24.305. We're going to add 24.305. So let's do 15.999 times 3. Let's remove this and remove this. So 15.99 times 3, right, plus 14.007 will give us that 62. Then we want to multiply this by 2. It will give us 124. Then we want to add plus 24.305. So the answer is 148.313. So that will also depend on the number of decimal places that's allowed. Okay, then the next part is this here. We are finding, we're given 0.97 moles of calcium carbonate. Okay, and by us to find the mass, so we're calculating the mass. But the formula for the mass is the number of moles times molecular mass, or M equals N times MR, M sub R. So M is the mass, N is the number of moles, and MR is the molecular mass. Okay, so in this case we're given 0.97 moles, so M equals 0.97 times the molecular mass for calcium carbonate. Okay, and we can calculate that using the masses for calcium. I think we already got this, and this. I think we've actually done this one before, but let's just do it again. So we need 3 oxygens. I think we can actually work it out from here. We've got the 3 oxygens, okay, but we don't want to multiply by 2. Okay, we want to add the calcium, which is 40, because we've got the oxygen. We don't want the nitrogen there. So let me remove this because that's nitrogen. That's the nitrogen. What is 24? 2405. That must have been, let's see. So we're trying to get the calcium. we know calcium is 40, and then CO3. So we've already got calcium carbonate. We've already got the calcium. We've already got the oxygen times 3 plus the calcium 40. So I need to be adding 40 here plus 40.078, right? 40.078, remove 1 0. So that's 40.078. So now I just need to add 1 carbon, and the carbon is plus 12.011, 100.086. Which was that one? So we've already got it here. So we just need to multiply this by 100 times 0.086. Okay, so it means, since it's all in brackets, we can just multiply this by 0.97. Okay, that didn't come off well, times 0.97, which will give you 97.0908. 97.08. Okay, then 2.7 moles of sodium hydroxide. So M equals 2.7 times the sodium chloride. Sodium is 22.99 and chlorine is this. What was the total for this one? Must have been 47. Let's see, 50. Must be this one, 58. So we're just going to say 2.7 times 58.443 is 157.79. So times 58.443. This will give you 157.80. Then 4.5 moles. I think we've already worked that one out. It's 145. And that's one with 148. We're just going to multiply that by 148.313. So 148.313 times 4.5. That should give us 667.41. So that's the answer to part 3. Okay, so this is part 3, this is part 2, and this is part 1. Okay, so let's look at part C. And part C says if I add 25 milliliters of water to 125 milliliters of a 0.15 molar sodium hydroxide solution, what will be the molar concentration of the solution be? So we use the formula C1 V1 equals C2 V2, where C1 is the concentration of the solution and C2 is the concentration of the diluted solution. So V1 is the initial volume and V2 is the final volume. So if you're adding 1.5 mils, it means you end up with what? If you're adding 25 mils to 125, it means V2 is 125 plus 25, which is 150 milliliters. And C1 is going to be 0.15, and you're looking for C2. You want C2, which you don't know, but you also know that V1, which you started off with, is 125. So V1 is 125 because you added 25 to make it 150, so it was 125. So you're going to put the C1. In fact, you want C2 to be the subject. So C2 is going to be C1 times V1 over V2. Okay, so C1 is 0.15 times V1 is 125 divided by V2 is 150. So that gives you 0.125 for this one, 0.125 m. That is the concentration. So that's C2. Then part 2 says if I add 100 mils of water to 100 mils of a 0.1 molar sodium hydroxide solution, what will be the molar concentration of the dilution be? So if we add 100 to 100, it means V1 is 100 mils and V2 is 200 because we've added 100 to 100 mils of 0.15. So C1 is 0.15 molar. So this is just going to use the same formula. So we're looking for C2. So again, using that formula, C2 is C1 V1 over C2, and in this case V1 C1 is the same, 0.15, but V1 is changed and is now 100 for this next calculation, and this is 200, so it's 0.0075. C2 is 0.00, not 0, just 1075 molar. Okay, so that's question 6. I'll see you in question 7.